Stefan's done talking, and just to prepare you, he's actually going to be telling some jokes. So I just wanted to let you know, look forward to that, and we'll see him in a little bit.
All right. Oh. Maybe you want to put that microphone on? How's that? You guys can hear me? All right. Is there enough oxygen still in here, or should we open some doors? If you guys back there, it's pretty hard working in the front here, so maybe you can put on the AC. Hey guys, thank you so much for spending the time, and thanks for the great introduction and setting me up between, the last phenomenal presentation launch. So I kind of have to figure out how I can catch up with that. All right, so I have quite a few slides, so I maybe speak a little faster, and I apologize, I have a strong German accent. So if you can't understand anything, just let me know, I'm happy to go into that. And just to give you a little bit context and maybe add some street credits here, I'm the founder of Datameer, but I'm actually one of the three guys that started Nudge. Anybody remember Nudge? 2, 3, okay. More than 10 years ago. Okay, so Nudge is the predecessor project of Hadoop. Okay, so I actually wrote the first HDFS implementation more than 10 years ago, and not just wrote a bunch of code, but also did the Hadoop elephant logo. So I really apologize if you think about the Hadoop elephant moving forward, you have to think in like a German accent, right? So, all right, so, but what I basically did since the early 2000s is consulting for a whole bunch of companies. Me and my team built Apple's iOS backend. You guys know Apple? No? Okay, cool. iOS backend, we predicted who's the next music star for EMI music. That was a lot of fun. If you, like a 20 years old engineer and Katy Perry walks into the office. We worked for Sun, HP, etc. So we did a bunch of projects before we even founded the company. And what really led us to found the company is the realization that what you guys just all talked about, every single one has the same problems, right? So in being an engineer, you try to optimize, so you build a technology that kind of solves it once and for all, and so not everybody has to implement the same kind of thing again and again and again and again. So anyhow, I will keep the advertisement part really short if you want to know more about this. You can see us in the back. But let me talk a little bit about some observations that I got from working on more than 200 big data implementations. Quick check, who's in, let's say, software developer here in the room? Like really writing code, okay? Who's more kind of the architect side? Okay, who's more on the business side? Okay, we'll do some little bit more workout to get you hungry for the lunch. So who has a Hadoop system in production? Who has one in the lab? Okay, who does not have Hadoop yet? Oh, quite a few. Okay, cool. So that might be valuable for you from kind of like how to think about this. So again, this will be less technical, but I'm happy to talk to you about compiler optimization later if you like to, or why Hadoop is actually batch and why Spark is also just batch, and why it doesn't matter. But today I want to really more talk about how to think about a few things as you plan your big data project, okay? And I will make some really big rounds, but I will bring it all back together, so just stay together with me. So one of the most recent Gartner study actually says that 60% of the big data projects will fail. What's pretty surprising, 60%. They even say 90% of the data lakes will fail. That makes me nervous working in the industry. I hope that, anybody nervous about that? No? Okay, all right. So here's what we usually see as we come, again, over the last almost 10 years. The big data project plan for companies usually starts with like, let's hire a chief data officer. Which company hired a chief data officer? Okay, couple, good. Okay, then they start cataloging all the data. They evaluate the big data stack, then they do really amazing bake-offs, HP against IBM hardware, and it's 1% faster, but 10% more expensive. So then, 3 months discussion, which hardware should we buy, starts. And then, of course, people build a data lake, right? Bringing all the data together, et cetera, et cetera. And then this big, amazing business transformation starts from moving the business from kind of gut feeling decision-making to data-driven decision-making. Does that sound familiar to someone? I see a few head nods. Okay, we usually see those fail. Let me explain why. So again, I will do some wide excursus. Who knows Moore's Law? Anybody knows Moore's Law? Yeah, okay, good. That was just to check if you're still here, right? If you're an engineer, you should know Moore's Law. So Gordon Moore, founder from Intel, obviously said that every 18 months hardware capacity doubles. And we have a really good track record. What is really interesting though is that his idea was actually picked up by Ray Kurzweil. Who knows Ray Kurzweil? Yeah, okay, that's cool. By the way, Ray Kurzweil has a phenomenal title. His title is the VP of the Future at Google. I really would love that title one day. I'm sure he has the most amazing toys. His Hadoop cluster, yeah, 20,000 nodes over here, no problem, right? But what Ray Kurzweil basically did, he took Moore's Law and projected it all the way back to the Stone Age and realized that Moore's Law actually applies to every innovation in the human history. Right? Every 18 months, we basically double our innovation capacity. And I think it's really fascinating. What he also did is then projecting that forward, and he realized that by 2025, machines will be faster than the human brain, and in fact, we will have non-surgical human brain computer integration. 2025. That's scary. But I think it's really, it's real. I the other day had a situation where there was an emergency, and instead of calling 911, I saw the person Googling first what to do. And that really was, really fascinating. And the person meant it in the really best possible way, and like, how can I help right now? And I think we're already seeing that there's a human brain extension into the cloud with our mobile devices. Right, so I mean, we all remember the time before the iPhone when we actually had to think about something, and we got into a discussion. And today we're just sitting in a bar. Oh, let me look up in Wikipedia. Oh, I'm right. So now we win much faster beers and bets. So thanks to the cloud and big data. So I think this is really important in the context of big data, because a lot of design decisions that are done today don't take in consideration Moore's Law or the acceleration of innovation. We come to companies that have still mainframes. Anybody has mainframe? Oh, okay, we should talk. We have a mainframe connect. I mean this in a good way. We have a mainframe connector. Anyhow, so a lot of decisions that you make today need to be valuable for the next 10 plus years, right? So if you're really focusing on which hardware you're buying today, you may be focusing on the wrong problem. So, and again, look, if you look about your kind of project time plans, you buy hardware today, and before you even have this whole thing rolled out, hardware is twice as fast already. Just keep that in mind. All right, I want to talk about flow, something completely different. Anybody heard about flow theory? Cool, few. Okay, so as we now thinking about human beings that have to interact with our big data stack and actually really find insights, what's really important is to make them incredibly successful. And Albert Einstein actually described flow before it was actually described in a very nice way. That is the way to learn the most, that when you're doing something with such an enjoyment that you don't notice the time passing. Anybody remember or had that situation, you're working on something and your phone rings, your husband or wife calls you like, honey, when are you coming home? And you totally forgot. I don't mean the bar, I mean kind of when you're working, right? We all had that situation. What's really fascinating is that actually Mikhail Csikszentmihalyi, took me 5 years to learn his name, Mikhail Csikszentmihalyi in the 50s and 60s did some phenomenal research work about flow theory, trying to figure out why after something devastating like the Second World War are people picking up and we have actually this thriving economies around the world. And he found out that when people get into the flow zone, something really phenomenal happens. Number one, we're switching parts of our brain off. For example, the part that measures time. And the reason we're switching this off is to funnel all the energy into our creative problem-solving part of the brain. And we're getting really, really good and really, really fast to very quickly, iteratively improve and work on our problems. And it's really fascinating. And if you look at this, it's described in this way. Basically, it's a sinus curve between challenge and reward, or a skill increasement. If it's too challenging and you don't get a reward, you're getting nervous. It's really frustrating. If you're just getting too much rewards and it's not enough challenging, you're getting bored. And by the way, flow can be applied not just to you doing data analytics on big data, or you be struggling with the Spark API or the MapReduce API. This can be applied to your job, to games, to general entertainment, right? But again, what is really fascinating is if you want to make you and your company super successful, what's very critical is that you help people to get into the flow zone. What means you have to lower the barrier to entry. And I want to talk about the barrier to entry a little bit here. And now I'm trying to bring this together. How can we make people more productive, getting them in the flow zone, working with data, finding insights that are really transformative for your business? But let's bring this in back with Moore's Law. And of course, again, my colleagues always joke I'm the biggest Apple fanboy, but that's actually not true. I also own Microsoft stock. It's okay. These days, it's okay. But let me play this really cool videos from 1980 with Steve Jobs. Let's see if the audio is working here. And he's talking about the barrier to entry for human beings working with technology. And I think it's, again, important as you think about your big data project.
We're very fortunate because the timing seems to be falling into place. In other words, as we move into the 80s, the amount of computational power, the amount of raw horsepower we can get into a small box for a reasonable price is staggering. Even in the last 3 years, since 4 years since we started, it's increased a few orders of magnitude. And one of the things that people always ask me is, what we've got right now is just fine. VisiCalc runs fast enough. Some of the database stuff runs fast enough. What are we going to do with this extra awesome power? And the answer to that is that we're going to put it into into solving that problem again. In other words, we're going to start chewing up power specifically to help that one-on-one interaction go smoother. And specifically not to actually do the number crunching and the database management and the word processing or whatever. We're actually going to start applying a lot of that power specifically to help us remove that barrier.
So 36 years ago, the founder of the now not anymore, most valuable company, second most valuable company, said 36 years ago, we will take computing power and lower the barrier to entry to make our people more productive. Now the question I have to you, why are we still, 36 years later, are so obsessed with super low level, highly optimized, pick your favorite open source project here, optimization that creates an incredible high barrier to people that are actually subject matter experts, to the people that actually should do the DNA sequencing, the genome research, the doctors, the trainers, the marketeers. And that's what we really see as we, again, engaging with hundreds of companies on a daily basis, is that big data projects are led by this fascination for the latest and greatest gadget and greatest toy, and is highly over-optimized on computational resources, but it makes the access to this wonderful data that is in there that could really change the world. We just heard from them. I mean, phenomenal, right? DNA sequencing, we could really have faster breakthroughs in science, in our companies, grow faster if we would just lower the barrier to entry. So I want you to think about, because I'm an engineer, I'm super obsessed with the latest and greatest API framework and this and that. But what we see is that the artificial barrier to entry to data and to technology, because it's maybe just Java APIs, now it's not even Java anymore, now it's Scala, let's learn a new programming language, or even SQL, good luck finding the tables, by the way. Why are we continuously building those systems and every few years updating them and totally forget about the end users? So I want you to think about this, and let me double click and bring this back to data analytics. One more thing. 10 years ago, what actually happened 10 years ago in the Western world, I have to say, 10 years ago, it flipped. 10 years ago, buying one more computer, one more server was cheaper than spending one more engineering day. 10 years ago, okay? So just keep that in mind. So data analytics, how basically we know it out of the university, out of your company, and how most of the companies out there preaching it was designed 40 years ago. In fact, SQL was invented in 1967. Just let that sit for a moment, right? So what we did here is that we optimized limited storage and compute that we had, because we spent millions and millions of dollars for hardware and software. We optimized the data to get more performance, right? Therefore, we invented a three-tier architecture. We first did an ETL step. You all know that, right? Extract, transform, load. And if data is the new oil, we clean the oil, we transform it, we kind of make plastic out of that, we heat it up, and then we melt it into our database that has a schema. The problem with our schema is that we design it today with knowledge from yesterday, and all the questions our coworkers told us they have to the data yesterday. And then we hope that we can answer the questions of tomorrow with the schema. Did anybody here of the engineers ever design the perfect schema ever? Inside?
Yes, I did.
Absolutely. I want to talk to you, and let's do some betting together, because you can tell the future. Yeah? Oh, yes, questions.
Opinion. That's not a limitation of SQL or relational database management systems. That's a limitation of the data model that's used.
The data, I would argue with you that in the last 20 years, well, studies show that in the last 20 years, the speed of business increased by 50x. And I would argue with you, whatever you design today is already old tomorrow. And that there is actually, if you look, the problem that companies have today is less of the data volume, because if you have more data volume, you just buy more Oracle or Teradata, pick your favorite. But it's actually the velocity of the data, the new sources, and then the structured and unstructured data, and oh, we just bought another business. Oh yeah, they have their own data warehouse, and oh, good luck integrating this.
I'm totally agreeing with you. All I'm saying is the reason why the data is outstripping is because the data model has traditionally assumed that we understand all of the business rules before we load data into it. That used to be okay, it's no longer okay.
We're 100% aligned. Let's have a drink later together. Spot on. You spot on, right? So we melt the data in, and then we put reporting on top, right? And the problem here, of course, is that it's not a technology problem, as you just said, it's a social problem. We go around in every department and we create a 200-page Word document by asking marketing, hey, what are the questions you have to the data? Then we ask sales, and we ask research, we ask operations, we ask DevOps, right? And then we put a PhD or a guy like me with sneakers, usually I have a long beard after, if I not speak somewhere. And then, we come up with this amazing snowflake or star schema, and that's just amazing, right? And in the end, most likely we end up with a key value store, more or less likely, right? So I've worked for, I see some people laughing, maybe you can relate a little bit, yeah? So I worked for this really hot gaming company, I will not tell the name, but it was really amazing. They built this amazing schema. 2 years later, they had one table was called stuff, and it had two columns, key and value. 98% of the data was in a table stuff. Wow. And I see this every time. So if you think about this approach is because we had limited storage and compute. We optimized soft, hardware, and most important, data to get reasonably enough query times out of this. And back then, guess what? Hardware was more expensive than human being. I'm so glad that hardware these days is cheaper than human beings. As a human being, I say that, right? I mean, in 20 years, we have a robot that will say, oh, that's not funny. Okay. But if you think about this, what can we do different? Okay, and I want to suggest something here. And that's actually the reason why we built a Hadoop in the first place. So this is technically called schema on read. You might have heard about that. What we can do is actually, instead of pre-optimizing the data because we maybe have storage and compute limitations that we actually do not have, just buy more, you know, pick your favorite. MapR is a really cool Hadoop implementation. Just buy a few more boxes. It's so cheap compared to the last time. Load the raw data, put it in Hadoop, and if you conceptually have unlimited storage and compute, because every 18 months you have twice as much computational power, what you now can do is you can do something that your Oracle admin said you never do for performance reasons. You do everything as a view. And I mean everything. You load the raw data and cleaning the data as a view. You aggregate the data on top of that cleaning view, and you maybe do your prediction on top of that aggregation view. Everything is a view and a view and a view and a view. Because computational resources don't matter anymore. It just doesn't matter. And the amazing thing about this is now you don't have one schema anymore. You have as many schemas as you want. Because you maybe have one clean data lens, right, or view, and then you create one virtualized schema for marketing, one for sales, one for operation, and instead of spending the next three months to discuss what the perfect star schema is, you just implement very clean review processes to agree on kind of like, what does the decision tree of data flow look like? So that you all agree what clean data is, but everybody slightly can have his, let's say, user ID calculated differently. And if you find out in 6 months that, damn it, you know, we need to do the user ID lowercase, that's just a view. You don't have to reload the data, you don't lose anything, but everything is a view. If you get to the point that you realize storage and compute doesn't matter anymore, it will help you to make a completely different decision about your architectural choices. And those will be more flexible, those will be more agile, and it will be more future-proof. Make sense? See, I'm trying to be extra controversial, comes with my DNA, I apologize. So happy to take conversations after the presentation and take it out there. This is called schema on read. And guys, here's my, I have to tell you, and that's kind of an interesting story. I did not believe in schema on read. It took me 6 months, conversations with Doc Cutting. Why the hell are we writing a storage and compute engine if we can use Berkeley DB and Nudge? And if you're interested, it's all in the open source mailing list. Go back and see the discussions. They're actually really phenomenal. And they actually talk about a lot of very interesting things, sequential versus random access, and that sequential access in memory is still magnitudes faster than sequential access. So this whole argument, oh, we will have memory in the future, or we have SSD and it will be much faster with SQL, they're all partly true. Okay, schema on read, makes sense? All right, I wanna maybe just one more metaphor to compare this. This is the old world we lived in, right? The manufacturing process in the 50s, 60s, 70s. We heat up the plastic, we heat up the material, we melt it into a mold. And yes, this is the cheapest way to do mass production, but I would argue 3D printing is absolutely transforming every industry, manufacturing industry sector, because of agility. And I think what you need in data analytics is agility, because we don't know what the results will be. If we spend 6 months thinking that we might find, again, kind of the DNA sequence that cures cancer this way, guess what? Maybe we find it, maybe not. Most likely we need like 10 tries to find it. So think about how can you accelerate the turnaround, like the whole idea of like, this is my hypothesis, that's my German accent, by the way. That's my idea, let's do a prototype, does it actually solve the problem? So in that context, I would like to propose a way how you can think about your big data project. And this is design thinking. Let me just quote the CEO of IDEO, Tim Brown here. Design thinking is a human-centered approach to innovation that draws from the designer's toolkit to integrate the needs of people, the possibilities of technology, and the requirements of business success. But it really puts technology as a tool in the end, and not necessarily in the beginning. And this is where I see companies fail. Because again, I'm an engineer, I'm guilty, I love my gadgets. Every month I have a new thing, and my girlfriend's getting totally annoyed with me because everything is stacking up, but I have to have the latest. By the way, if you want to win this Amazon thing, it's freaking phenomenal. It's just phenomenal, but it slows your company down. So let's look at this. So design thinking is really multiple steps here. First of all, emphasize, then define, ideate, prototype, and test. And actually, I highly encourage you to look for companies that implement the design thinking in the overall business process. They actually perform 100% better than the SP 500. And they just made it a part of their business model. So how do we apply that to big data analytics? Well, first of all, I would argue you need to start with use cases, requirements, and barriers. And I will show you in just a second how you can do this super simple with sticky notes. Then you need to define actually what is the use case you want to implement and look for some ROI. Then you start talking about how can I implement the use case. This is where you maybe the first time really talk about should we use MapReduce, test, Spark, which technology, do we need streaming or not? And then you prototype. What is so phenomenal and interesting for me is like every company I work with, they're like, oh yeah, we're totally agile. And are you guys doing Scrum, Agile, anybody? A few, oh cool. So they do agile development, but not necessarily have an agile approach to their architecture. Right? They're like, okay, we do 2 weeks, 1 week sprint to implement, but they don't think the same way about an evolutionary process of the technology. And that's the problem. So you have a waterfall approach for your architecture, but you have an agile development process. Kind of interesting. So I will encourage you to maybe think that the other side around. Okay, so prototype is very important. And then validate is actually the analytics you want to do, bringing the ROI that you expected. When you can answer this with yes, let's talk about streaming or batch. Let's talk about encryption, operationalization, REST APIs, monitoring, all that kind of stuff. Because I can guarantee you the first few tries, or let me rephrase it, you're very lucky if you hit it with the very first try, right? All right, so and the important thing is that you do this as a rinse and repeat, right? It's nothing else than agile, but bring that back to your overall big data architecture as well. And rather think about building a big data infrastructure in a way how you think about evolution. Every week you're testing and stretching your big data architecture, and I can guarantee you that I did not see people really running into dead ends when they do an agile approach. People are smart, they know, okay, eventually we need maybe streaming, so we leave this API open, or we implement this in this way. But when people start with like, oh my God, we need this real-time performance, the whatever thing, and then the marketing user comes, yeah, I need this report once a week, then there's a disconnect between what the business requirements are and kind of the amazing spaceship you just built it. And this is where we see big data projects fail. So think of your analytics in an iterative process, really integrate, prep, analyze, visualize, test your ROI, and do it again, right? Try to measure yourself, how fast can you do this cycle? And I'm not talking about writing software, I'm talking about doing analytics. And it's fine if you, again, have, I don't know, start with Tableau and then eventually move it to Hive and eventually move it to something different, but keep that schema and read thing, right? Hive, schema, read. Okay, so one thing that we saw is when you put together big data teams that, again, analytics teams, important here, we see kind of 4 rules that are important. You need the one visionary that kind of consistently spreads out idea. How about this? How can we combine DNA sequencing data with kind of weather influence to that person, for example, right? The guy consists, or the woman always comes up with ideas, right? And sometimes, again, brainstorming far out there. Then you need kind of the other guys like, I don't think that water data does make sense in this context, right? You need someone that stress tests your ideas, but you need that person that is, excuse my German, crazy and just consistently churning out ideas. But you need the one that stress tests as well. Then you need the guy that kind of like, hey guys, come on, let's bring it back to earth. Even if they find like an amazing idea, okay, water data and DNA data makes sense. Come on guys, let's not make like that big jump. Because the problem, even if you have an amazing, innovative idea for an insight, your organization might be not ready. So you have to consistently have someone that also brings you back to earth, right? Even if you kind of came up with the most amazing thing. And then you just need someone that gets stuff done. And that guy usually, or girl, or man or woman, is usually not the person that has ideas. It's also not the person that's consistently critical, right? We all know that guy. And the guy or woman is very important that consistently challenging our ideas. I have those people in my organization, and I really appreciate them. Maybe not right in that moment, maybe not at 5 p.m. on Friday, but it's very healthy to have those people that consistently challenge you, and together you get together. In fact, if you want to learn more about this, we did a research study with Stanford University, really phenomenal. They transcribed design thinking teams and then used path analytics with Datameer to identify what actually results in faster cycles in innovation. Humor was, by the way, so cracking a joke here and there was actually, by the way, very positive in accelerating innovation, or I thought was interesting. What's difficult? Humor, software engineers, right? So, all right, so here's what I would recommend you guys considering, because we see that very successfully, and I promise this is my last couple, 3 slides here. Think about, before you even think about your architecture, think about doing a discovery workshop. Group people to 3 to maximum 5 people. Those groups should be cross-functional, so have a data analyst, a business person, and an IT person in that group. And the reason you want to have small groups is because the social norm in small groups is to speak up. If you put everybody in the table, you have like 20 people on the table, the social norm is actually to be silent. And a really cool side effect is also, if you have multiple small teams, you can put your boss in just one of those teams. And I'm or kind of that cranky guy that always challenge everything. Because again, everybody has a place, and those folks are very, very important. But you also really, truly want to do a brainstorming on use cases. And then what's important is that you start asking questions with if the world would be magic. Because here's the challenge. Our thoughts are so tinted about the technology limitations that we experienced in our last 10, 20 years, that we maybe are afraid to kind of ask critical questions to the data, right? And we see this all the time. People think in maybe, track and drop Tableau, but then they don't think in like time series analytics or path analytics or clustering, because it's just not there right now the last 20 years. So really, really say, if the world would be magic, ask some questions. And then take some sticky notes, put the question on the sticky note, very simple. Every team puts it up on the wall. And then something super simple, but that's the magic. You put on, you bring everybody together and you score them. And you score them in a way that everybody, without discussing with the other, gives a gut feeling on the score. And this is the concept of the wisdom of the crowd. And this is, by the way, very interesting book. So in the, I forgot, 20s, 30s, a mathematician in London actually realized that they had this farmer's market, and all the farmers would bet how much meat comes out of a cow they would slaughter. And he realized that actually the average of all the bets is within 3% accuracy. So as you have a cross-functional group, just ask everybody, what do you think? What's the value of this use case? And just put it down, because the value for IT might be completely different than the value for business. But also maybe the difficult score that you define, maybe it's very difficult to do this from a business perspective, data privacy requirements, or Johnny over there, he will never give me the data, where then maybe IT thinks, oh, this is super simple, right? So create a score that really comes out of the group, and create 2 scores. Number 1, what's the effort? How much, just gut feeling, what's the effort, let's calculate an average, and what's the value of this use case for the business? Gut, create an average. And what you then do is very simple. You sort your use cases by lowest effort and highest value, and then you keep cranking in a 2 weeks iteration. Make sense? Sticky notes, who thought, right? Again, I highly recommend to try this out. It's magic. Oh, I forgot to put in the Gartner logo, sorry. So in that report that you can also download on our website from Gartner, Gartner really says prioritize incremental improvements over business transformation. Because the hardest thing isn't technology, the hardest thing is to transform a company. And what we found is that if you do this incremental improvements and you show quickly value, even small value, you will be the big data hero. But if you go out and say, I can do this, and 2 years later, they are still an unstable, not completely value-providing platform there, you will have a problem. So I highly recommend to rethink how you approach this. So instead of hiring a chief data officer, I would advocate hire a chief growth officer. So again, I'm trying to be controversial here. So hire someone that thinks about use case and how to drive the business forward. And then bring the team together, identify the use cases, implement the use case prototype, implement kind of the minimum viable product of your big data platform, and then just keep incrementing on all of those things. We saw people with this approach being phenomenally successful very quickly with companies. TIA Craft lowered churn with Datameer 50%, $100+ million ROI. Guess what? Took 8 weeks. 8 weeks. But if you go out for 2 years and build this amazing spaceship, it's really cool, but it's maybe not valuable for the business. So my last thing, if you're interested in one of those use case discovery workshops, let's say the first 3 people that talk to me that can bring 10 people into that discovery workshop, cross-functional, I come in person and do that for you. How about that? So give me your business card, but you have to bring 10 people. Business, IT, and data analyst, if you're interested. With that, well, again, I hope I didn't spend too much time and destroy all the dreams about the wonderful gadgets. They're still out there. But again, I'm doing this since 15 years, folks. And this is just some ideas. I'm not, I don't have the solution for everything. But I would challenge you to think about schema on read versus schema on write. So SQL and Hadoop, building tables, Hive, might be not the best solution. Might be not. So think about that. And I would like to encourage you, even though you IT and you software developers, to encourage your organization to do first the use case discovery and really understand then the requirements of those use cases that are low-hanging fruit before you go out and implement this amazing Kafka real-time Storm platform. And by the way, I still have code that I wrote 10 years ago in Storm and Kafka, so I like if you use those platforms. But I can guarantee that, again, if you put technology first, you struggle, so put the business first. Thank you. Enjoy lunch.